Hi everyone. So in this video we are going to learn about graph theory. So let's get started. So what is graph? So you already know what is graph. A graph, a network G equals to V and A consists of set of vertices, points, nodes, and V a set of edges. Such that edges in E connection between a pair of vertices in V. Alright. So you already know this is 1, 3, and 2, 4, 5. These are vertices and these are edges like 1 to 3, 1 to 5, 1 to 2, 2 to 3, and 2 to 4. So vertices are 1, 2, 3, 4, 5, edges are 1, 2, and 1, 3, and 1, 5, 2, 3, 2, 4. These are some edges. Okay, so now you can see that vertex set equals to v1, v2, and V3 and V4 and V5 and V6, and edges are E1, E2, E3, E4, E5, E6, E7. So E1, E2 and E3 are incidents on V1, and V2, V3 are adjacent to V1. Like this, you can see that. I will show it. I will keep myself to left. Now it's fine. So these are even. Now it's okay. It's fine now. Now you can see that E1, E2 in E3 are incident on V1. E1, E2, E3 are incident on V1. But V2 and V3, V2 and V3 are adjacent to V1. Like this, you can see that. I'll change the colors like this. V2 and V3 are adjacent to V1. Now you can see that E2 and E3 and E4 are adjacent to E1. Like E4, E2, E3 are adjacent to E1. Okay, and point 61, point number 6, V5 and V6 are adjacent to themselves. V5 and V6 are adjacent to themselves, and V4 is an isolated vertex, and E4, E7 are loops, and E2 and E3 are parallels, and the endpoints equal to V5 and V6. Okay, so these are some definitions of vertex edges and which are adjacent and isolated. What are before is isolated because it is alone. Nobody is connected to V4. So now the next chapter path. What is path? A path of length k is a sequence V1 Vk of vertices such that Vi plus 1 for I equals to 0 and 1 to k minus 1 and edge of G. And AEB is a closed path. BCD not a path. Like that, you can say AEB. It is a closed path because it is a close, and BCD it is a not closed because here it is not. Okay, you can see that there is no edges between B and C. All right. So now you can see the simple path A E K P L Q M H D C G. No repeated vertices. So length of path is a number of edges in the path. Okay. So now Next will be definition of cycle. Alright, a cycle is a path that starts and ends at the same vertex. A simple cycle has no repeated vertices. What is simple cycle which have no repeated vertices? Okay, so these are some examples. You can see that A, B, E, D, F, G, C, D, H, G, M, E, K, J, M, N, O, P, Q, like that. J, K, N, P, O, K. Yeah. J, K, K, J, N, P, O, K is not simple because it has no repeated vertices. What is cycle? Cycle is a path that has start and end at the same vertex. It is known as cycle. Alright, so now subgraph. A subgraph H of G is a graph if its edges and vertices are subset of those of G. Edges and vertices are subsets of G, like that. Vertices will be B, D, E, F, G, H, L, P, Q. And okay, edges and vertices are subset of graph G. That is subgraph. And edges will be here, E, H, B, E, and B, J, E, F. Okay, D, H, L, P, L, Q. Alright, so now what is tree? A connected graph T without any cycle is known as tree. Okay, tree and free tree, you can say that anything. Tree or free tree, you can say anything about that. There is a unique simple path P between any nodes U and V in T. A group of trees called forest. Okay, so you can see an example of trees and forest. So definition of vertex in a graph. The degree of vertex V in a graph G is written dV is equal to number of edges in G incident on a vertex V, and each edge is counted twice in counting the degree of vertices of G. Therefore, sum of degree of the vertices of the graph equal to twice of number of edges in E. I think sum of graph E and to say two times of number of edges in graph of G. Alright, I have it. So now, a vertex said to be even and odd if its degree of that vertex is an odd and even. A vertex degree 0 is called an isolated vertex. So you know what is undirected and directed graph. A graph is directed, digraph is it is contain a finite set of vertices V and set of order pair of distinct vertices called arcs or direct edges. Edges U notated as U implies V. Right? It is rotation for directed graph. A mixed graph contains at least one edge and at least one arc. An undirected graph is treated as two direct edges in opposite direction, and out degree V is the number of arcs beginning at V, in degree is the number of arcs ending at V. Each arc beginning, source, and end destination at a vertex. Theorem will be a sum of out degree of the vertex of digraph equal to sum of in degree of vertex, which equal to number of graphs in G. As in G. Okay. So now it is connected and disconnected. G is connected if there is a path between every pair of the vertices. If G is not connected, the maximal connected subgraph or connected component is G. For undirected graph, G equal to vertex, and if G is connected, then E greater than H is greater than equals to vertex minus 1. If G is tree, then E equals to vertex minus 1. And if G is a forest, E less than V minus 1. Okay. So this is out part 1. Next, we will discuss some important terms. So this is graph theory first part. So thanks for watching. Like, subscribe my channel so that you don't get miss any update from my side. Okay. So Thanks for watching this video.